Next up, we have Don Shinn from IAC, where Don leads system sales and is a project manager. Please join me welcoming Don. To advance your slides, just hit that button. Thank you.
Good afternoon. We appreciate the opportunity to make our presentation here today and to be a valued sponsor of this event. A little bit about IAC. We're an EPC contractor, primarily. We're based in Overland Park, Kansas, in the Kansas City area. We've been in business for almost 40 years now. We have employees exceeding 200, over 60 engineers based in the Kansas City office. We have personnel located throughout the country in either sales or support roles for our Adelphi Construction Group, which is a wholly owned subsidiary. A little bit about what we do is we're really kind of an opportunistic EPC contractor. EPC, for those of you who don't know, stands for Engineering, Procurement, and Construction. Not only are we a contractor, but we are an OEM of air pollution control equipment, primarily dust collectors for particulate control, fine dusts, as well as for hot process gases. Also, we have a thermal group that produces rotary dryers. We've done that in the frac sand industry and in the biomass industry as well for drying wood products and dried distillers grains in the ethanol industry. Our focus is primarily on industrial plants, large-scale plants, which Tom Miles and others in their report about 2 or 3 years ago mentioned would be somewhere in excess of 100,000 tons per year. Some may be smaller than that, and we're not going to turn away a project because it's 50,000 tons per year, for instance. But typically, when you build a plant of that scale, you're looking for a reliable plant that's going to run 24/7. It's going to be 8,400 hours a year. And these plants in the biomass conversion space, typically you're looking at producing biocoal, which is, I guess, the new term now for what was torrefied wood or black pellets, as opposed to white pellets in the white wood pellet space. Biochar for either carbon markets such as agricultural use or PFAS remediation, activated carbon, and then biocarbon, which is meant to replace metallurgical grade coals in the steel making and metallurgical markets. And then along with that, cogeneration with biochar to produce heat and or power. And the economies nowadays may very well dictate that you need to do this. And in order to do a lot of that, you may have to co-locate a plant near an existing facility, whether it's a pulp mill or an ethanol plant or other potential user, a customer for your heat. And also the economy of scale for a large plant allows for a lower CapEx and OpEx per ton. And this product is typically going to be recognized as an industrial commodity at these levels. What we're seeing now is a great interest. There's going to be a demand for electrical energy here in the U.S. because of certain drivers, electric vehicle adaptation, adoption, shuttering of some of the fossil coal-fired power plants, population growth, climate impacts, perhaps from additional air conditioning needs, load reserve requirements. As the demand increases, the utilities have to maintain a certain load reserve as well. Tremendous data center growth, which is occurring at present, cryptocurrency mining, and AI growth, which is going to be, from what we hear, going to be a tremendous driver. A lot of interest from all the large Silicon Valley folks. In looking at the raw material resources that are available from the 2023 billion ton report assessment, there is over 1 billion tons of available raw material resources, of which forest products is just a small part of that. If you look at the currently used biomass for energy, a lot of that is going to be essentially corn for ethanol production, oil seeds for biodiesel production. There's a bit of MSW that provides for energy needs. And, but there's a great interest in forest lands for either fire mitigation, remediating those areas of the forest that are beetle kill, and also to utilize those raw materials that would normally decay naturally. Rather than that, well, let's take those, let's process those, refine those so that we can create a biochar that could essentially be sequestered, for maybe 1,000 years. So doing our part to try and reduce carbon emissions. One of the industries that we've been involved with over the last few years now has been the ethanol industry. One of the plants that we helped participate in building was Red Trail Energy, which is located in North Dakota. And originally we installed that plant along with 3 others, coal-fired fluid bed combustors that then went through a heat recovery steam generator. And we placed the emission control equipment behind that, some large bag house collectors along with the ash collection, handling, storage. And then because it was coal, we also introduced dry sorbent injections to try and mitigate whatever kind of heavy metals might have been in the coal to begin with. But the ethanol industry is very active now in pursuing other markets. They've always been very forward-thinking. Rather than just producing ethanol as a fuel, they co-produce dried distiller's grains or wet cake if it's not dried, and corn syrups. And there's a very pure stream of carbon dioxide that is emitted from these ethanol plants. And so that's either marketed to the beverage industry, and now they're looking at taking that and sequestering it or using it for oil extraction, enhanced oil extraction as well. So it demonstrates that an industry, once it's been established, it has an opportunity to really bolt on additional markets. So when you look at industrial scale biocoal, biochar, biocarbon cogeneration facilities, there are a number of segments of that. And those would be, of course, the transportation routes into, out of, and around the plant, whether that's by road, rail, or water. The raw material storage, pre-processing, whether it comes in log form, or if it comes in as chips from the forest, where they've been chipped in forest, or potentially large bales, if perhaps it's corn stover, or maybe it's sugar cane bagasse or sugar cane waste from the fields comes in large bales and must be then further ground and processed. Usually that material needs some amount of drying. You might have moisture contents 50% water. So there'll be a drying step that's then followed by the thermal processing, pyrolysis or gasification, and then product cooling of the material once it leaves the thermal process, and then depending upon what the final form factor that your customer is looking for, then it may very well be pelletized or at least densified. And in order to do that, you may very well be adding binders and then cooling it. So that's a solid portion of it. The syngas from the process will need cleaning and then combustion to drive the process, or depending upon those percentages, would be sent through heat recovery steam generator to generate power or generate steam for a further process. The other thing to always remember in any of these large-scale processes that there's a real need for safety and hazard integration. And beyond that, pollution controls as well. So when you look at raw and pre-processed material handling, what we have here are examples of essentially wood chipping and handling. We have partners in our industry that are in that particular industry, and so they have a great interest in using those materials as raw materials. So that raw material is then going to have to be transported and then further processed into smaller sized particles. So you're looking at taking green raw material and then having to process it either with mobile equipment in the forest or process that on site through some form of whole tree chipping. When you look at drying, rotary dryers have been involved in the forest products industry for drying wood chips and materials for decades. They originated in the alfalfa dehydration industry in the Midwest. And those companies that were based in Kansas then actually sold those dryers into the forest products industry back when we were first making particle board. We grind wood up, make small particles, and then that became strand board and later wafer board or medium density fiber. So a lot of those dryers originated in the forest products industries. Those are higher temperature, which means that you have an inlet temperature that may approach 1,000 or even furnace gases that are in excess of that, 17, 1,800 degrees. And what we would do with our dryer systems, and many others do as well, is exhaust gas recirculation to take a portion of that to provide a safer environment with higher moisture content gas that is then recirculated, and it drives down the inlet temperatures to protect the wood that's going through the dryer system from being over dried or scorched or case hardened. So they do require advanced pollution control equipment, especially on the scale that we're talking about here. When some of the original wood pellet plants were built and introduced, 10-foot, 12-foot diameter triple pass rotary dryers, and there was a lot of blue smoke from those. And I was a part of a design where we patented essentially a reverse pass, triple pass dryer that helped to reduce those. But primarily the material is separated from the airstream in cyclone collectors. You typically don't put a bag house behind a rotary wood dryer because of fear of fires and explosions. And those are typically then followed by a wet ESP or maybe a regenerative thermal oxidizer. There are lower temperature dryers, which have high gas volumes, but lower temperatures to get the same kind of results. Those might be belt dryers, or they could be a rotating disc dryer, similar to those that Dryer 1 in Belgium is producing. Belt dryers, typically European designs as well. On a small scale, they may very well not require any kind of further air pollution mitigation, much like a small rotary dryer with a single cyclone collector may not require it as well. So it's really kind of dependent on the volumes and the type of wood and the emissions that might be expected from those. So pyrolysis reactors, thermal reactors, these are mature designs, looking at usually indirectly heated calciners, or they may be some that are centrally, more directly heated as well. So those are, like I say, mature. They have limited outputs. So in many instances, you're going to have to gang a number of those together. They're quite expensive. They operate at very high temperatures, and so the interior drum is usually made of a very exotic steel. And they see a lot of growth as the steel is heated up. They're quite expensive as well. So IAC is working with our partner company, looking at ways to try and use indirectly heated rotary calciners, which could be used for mineral products as well, but specifically for the forest products industry. And we'd invite you to come by our booth and visit with our technology folks there to learn more about those. Typically, we're looking at very high volume machines here. So depending upon the form factor of your final product, you're going to be looking to densify that. A lot of the densification originated from the feed milling industry. And so the original white wood pellet mills used the horizontal ring die pellet machines. And then the folks from Europe brought the flat die machines, which offer a very good alternative. Newer machines now, looking at pin mixers, which some folks are here at the show that you can visit with them about that. Typically, those are going to produce a very small particle or a granule that will then have to be maybe further agglomerated in some kind of a disc pelletizer, or you can put the material through briquetters. When you get to a material like biochar, you're going to need some form of a binder, along with probably a great deal of water, to be able to get a pliable mixture to create the final pellet. In the whitewood pellet industry, there's enough lignin left in the wood to maintain its shape as it goes through the dies. And as the whitewood industry was looking to create torrefied wood pellets, they have to look at, of course, reducing some of that through the torrefaction process, roasting that out. And so they may or may not have sufficient lignins left. And as a matter of fact, there's some whitewood pellet producers that actually add lime and other fillers to their material as well. Important safety measures, especially for drying, would be any kind of fire water deluge activated by temperature sensors, gas duct safety gates, explosion protection in the way of explosion vents, gas monitoring, And then spark detection and suppression using infrared detectors and very high pressure short bursts of water spray to extinguish sparks as they're entrained through the gas stream. Solids storage considerations. There was a very good speech yesterday about some of the opportunities for storage of some of these materials. I think we're going to find that large-scale storage is probably going to have to be resolved. Explosion venting, of course, would be required. Nitrogen blanketing, which is kind of borrowed from the petroleum industry. And there have been, a number of cases where there have been events where storage silos have burned, or even with white wood pellets for an extended period of time. There's also concerns about ocean transportation, even with white wood pellets, where volatiles may still be emitted as these pellets are transported across the oceans. So those concerns would also need to be realized with biocoal or torrefied pellets, or also with any kind of biocarbon, biochar products. Transportation and safety of that and storage are going to be paramount. Cogeneration, there are modular gasifiers, which the fine folks at PIREG have offered. Also, some larger scale auger gasifiers that provide the gasification chamber followed by thermal oxidation, and then that heat is then sent through a heat recovery steam generator to generate both power and hot process steam for the host plant. Typically, those large-scale units are going to be located and co-located, with other major users of those kind of heat needs, where a smaller modular unit may very well be located in some remote area to provide, not only its own power, but power to the grid to, remote rural localities. The HRSG heat recovery steam generator, there are several suppliers of those, and steam turbines. The ancillaries, mean that you have to have the water treatment for the boiler system. You'll have to have condensers, either water or air-cooled condensers, and a whole host of equipment that accompanies a heat recovery steam generator. For mitigation of hot process gases on large-scale rotary drying installations, you'll be looking at a wet ESP, followed with an RTO, the regenerative thermal oxidizer. The wet ESP is there to knock out particulate so that it can avoid poisoning the beds on the RTOs. And we're also seeing a lot of SNCR, selective non-catalytic reduction, with injection of urea for NOx reduction as well, especially on such large processes with such large volumes. The bag house and fine storage, the photo to the right is of a bag house that we supplied behind a coal-fired fluid bed combustor and HRSG at 4 ethanol plants, as I mentioned earlier. And then we provided the ash recovery and storage systems, as well as a separate silo for a dry sorbent to be injected into the flue gas stream as well. So when you look at some of the scale essential production, it scaled from a mere 20 million up to 400 million gallon per year plants in just over 20 years. And essentially, ethanol production helped save American farmers. I mean, there was a period of time when corn prices were so low that farmers were going out of business. So they welcomed the opportunity to provide ethanol to help supplant the existing petroleum, the gasoline that we use in our fuels. And so now you're looking at 10%, 15%, even more for certain engines. And so that's been a real a lifeblood for rural communities. Another industry that we've been involved in was frac sand, and maybe a lot of people don't know this, but most frac sand is dried, and it's dried only because you can't screen wet sand. So about 10 years ago, most all of the frac sand came from Wisconsin, St. Peter's Formation, Minnesota, Wisconsin, in the upper Midwest and along the Mississippi River. And then it was loaded on rail cars and then shipped down to the Permian Basin or to Oklahoma, Louisiana. And what you'll find is that a unit train, 100 cars, is like 100,000 tons, is going to go into one bore. And so it was becoming prohibitive to have to ship that all the way from the north down to the southern states. So they looked for another alternative, and they found sand dunes in Texas and in Oklahoma that maybe they're not perfect, but they're good enough. And so it started an entire gold rush, if you will, for local sands, where they merely had to scrape off the top of the dunes and then extract it, wash it, and then dry it, screen it, size it, put it in silos, and then load it out for use in the fracking wells. And we were lucky enough to build about a half dozen plants, throughout Texas and Oklahoma, and all of this within about a 3 or 4 year period of time. So, when these markets present themselves, typically they're going to scale up very rapidly, and they may not last, that long before all the plants and equipment are built, and they're all in production. And once that occurs, then you'll have, buyouts of some of the lesser efficient operators by some of the larger operators, and you have a consolidation. Wood pellet production, similarly scaled up to 800 million metric tons per year in a single plant, and that all occurred in about a 40-year period of time. Originally it was small sawmills, family-owned businesses looking to make pellets that it was a chicken and egg. They needed a market for that. So along came suppliers of wood pellet appliances, stoves that for central heating or for home heating. And then the new regulations were enacted and new markets from essentially European countries to utilize the wood pellets as a fuel source to either augment or replace the coal that was used in their power plants. And so you had companies like Green Circle emerged, and then later Enviva and now Drax, which have 100 millions of tons of wood pellets produced annually. And now our latest market, biocarbon production. This here's a photo of the SDI plant, SDI Biocarbon Solutions in Columbus, Mississippi, which we're honored to supply the 2 rotary dryer systems for their process, expected to generate something like 200 million metric tons per year of biocarbon that will be densified, pelletized, and then used as a replacement for the anthracite coal in their steelmaking process. So we see this as being just really the first. There's efforts being made in Europe and in Canada as well for the steelmaking industry. They're looking to try and reduce their carbon footprint. You know, there may very well be other markets that are going to present themselves. And what we would just like to be remembered as a contractor who can assist in trying to you know, create those much larger plants and larger facilities. Thank you.